Hello everybody, today we are estimating quantities. So when we're doing powers of 10, we can use powers of 10 to estimate and compare really large and really small quantities. We're going to fill out the tables to represent the actual values of large and small powers of 10. So in this first chart right here, we have 10 to 0, and anything raised to the 0 power is 1. And then we have 10 to the first, which is 10, 10 to the second, which is 100, and 10 to the third, which is 1,000. And you can see a little pattern here that when I had 10 to the first, I added a 0, and 10 to the second, I added 2 zeros, and 10 to the third, I added 3 zeros. So your job is going to be to fill in the rest of these boxes right here. So I want to know what 10 to the fourth is, 10 to the fifth is, 10 to the sixth, and 10 to the seventh. Now, these are negative exponents. So again, 10 raised to 0, anything raised to the 0 power is 1. Now we have 10 raised to negative 1. So I've taken my decimal point and I've moved it. So when I do that, I get 0.1. So notice I didn't add a 0, but I've taken that tenth, because this is a tenth, 1/10. So now I have 10 to the second power, 10 to the negative second power. So I'm going to have it's going to be 1/100th, 0.01. Then I have 10 to the negative third. So I have 0.001. And you can notice a little pattern here starting to develop, that when I had negative 3, my 1 is in the third spot to the right of the decimal. And the same can be said for 10 to the negative fourth, that my 1 is in the fourth spot to the right of the decimal. Okay, so this one is 3 spots to the right of the decimal, this was 2 spots to the right of the decimal, and this is 1 spot to the right of the decimal. So you guys are going to need to fill in 10 to the negative fifth, and so on. So when we're estimating with powers of 10, to estimate a number using a power of 10, you're going to round the value, then rewrite the value as a single digit times a power of 10. For example, we can estimate 9,450 with 9 times 1,000, or we could say it as this, 9 times 10 to the third. Because really what we've estimated this to is 9,000, because it's closer to 9,000 than it is to 10,000. And you can always kind of represent this as, my target number was 9, I can look to the right, it is 4 or below, so the number stays the same. Additionally, we can estimate 0.000879 with 9 times 1/10,000th, or 0.0001. And remember that 1 is in the fourth spot to the right of the decimal, so my exponent is going to be negative 4. So I have 9 times 10 to the negative fourth. Now you can be looking at this and say, oh, well, there's an 8 there. Well, again, I estimated. Okay, so I can look to the right of my number here, which was 8. It is 5 or higher, so I can round 8 to 9. So we're going to estimate the following values by rewriting as a single digit times a power of 10. So let's take a look at this first example. We had 720,432. Well, I've rounded it for you, and all of these I did round for you. So we want to use the number 700,000. So we can write it like this, which was our first example right up here, as 7 times 100,000, which is going to give me 700,000. Or I can write it like this, as 7 times 10 to the fifth. So this second row right here should all look the same. So it's going to have your target number times either 1,000, or it's going to be 1,000,000, or so forth. All right. So, but look right here in our box in number 2. When you fill out this box in number 2, it should look a lot like this example in number 1. Okay. So we had 2 times 1,000,000. So again, you can just write 2 times 10, and there are 6 zeros here, so it would be 2 times 10 to the 6th. All right. So you'd be writing 2 times 10 to the 6th in this box right here. For number 3, we had 12,678,200. And I rounded that for you. Now I rounded it down to 10,000. It's a very friendly number, all right, because we would be rounding this to either 100,000 or 10,000. Again, the rounding was a little bit difficult to identify, so I did it for you because the answer sheet was a little weird, but this is what was on the answer sheet. So my middle box needs to look a lot like the middle row right here. All right, and if you're going to do that, you can always have, right, 1 times 10 to the 7th, which means I'm going to have 7 zeros after the 1. And that's going to make 10 million. Sorry, 10 million. So for number 4, our decimal was this. I rounded it to 0.002 because I looked to the right of 2. It was 4 or below, so the number stays the same as 2. I have 2 times 1,000th or 0.001. So I need to write my answer in something that looks like this. So for example, I could have 2 times 10 to the negative third because the 1 is 3 spots to the right of 0. Okay, and for number 5 and 6, I don't think I need to explain myself any further. Okay, take those 4 examples and apply them to 5 and 6. So we had some word problems down here. And again, they made us estimate, so I filled in those estimations for you. And I'm going to read through them. For number 7, it says, in 2015, the world population was about 7 billion. The population of the country in red lived in was about 7 million. Approximately how many times greater was the population of the world than the country that Rhett lived in? So the population of the world estimate as a power of 10. So the world population is right here, which is 7 billion. Okay, so we would have 7 times 10 and then count our zeros. 3, 6, 9. So we could have 9 right there. Now, the population of Rhett's country estimate as a power of 10, we had 7 million times 10, so it would be 6 zeros. So we had 9 and 6. So how many times greater is that? It is 3 times greater. Right? So you could say something like 3, right? And I'm going to try to fill in my box real quick for you guys. All right, 3 is my exponent, because this is how many times greater it is. All right? But I want you to fill in these 2 boxes right here, because this is a little bit of a lesson from the top of the page. So again, you're going to count for the world population, okay? There were 9 zeros because it was 7 billion, so you would write 9 here. You would write 6 here, and I subtracted 9 from 6 to tell me how many times greater it was. Now it says, for number 8, the diameter of grain of sand measured about 5 thousandths inches, or 0.005, while the diameter of the dust particle measured at about 0.00005 inches. About how many times larger is the diameter of a grain of sand than a dust particle? Well, the grain of sand estimate was 5 thousandths, right? So I need to count how many spaces the 5 is from the decimal. So I had 1, 2, 3. So again, very similar to the top right here. So boom, 1, 2, 3. Okay, now the dust particle estimate as a power of 10. Well, the dust particle had 5, how many spots to the right of the decimal? 1, 2, 3, 4, 5. So you can fill in your answer right there. And then how did I get 2? Well, I took 5 and subtracted 3 to tell me how many times greater it is. So basically you can think of this as how many more zeros does this have for your dust particle than the zeros you have here for your grain of sand. So it's basically telling you how many extra zeros you have. Alright, so this one had 2 zeros, and this one had 4 zeros. So how many extra are there? Ooh. Uh-oh. There was 2 extra zeros. My highlighter's being a little weird. There we go. So I had 2 extra zeros. Alright, for number 9, I'm going to ask you to try this one on your own. It should look a lot like the top. So for number 9, it says a small town in Texas started a population of, I estimated it for you, 1,000 people 50 years ago. Now the town has experienced significant growth and has a population of about 1 million people. Approximately how many times larger is the current population in the Texas town than it was 50 years ago? So the population of 50 years ago was 1,000. So this is your first one right here. So you can write that very similar to this top example above it. All right, and then the next example was the growth of the population, right? So the current population. So the current population is right here at 1 million people. All right. And then how many times greater? Well, I can even kind of see that I have 3 more zeros than this problem. So I already kind of know that it's going to be whatever you think. All right, that's going to be it for today. Everybody have a great day and stay safe.